Okay, next we will calculate the capacitance of capacitors which are connected in series or series combination. Here again I consider three capacitors which are connected in series, and these capacitors are connected to an external battery. So here we have positive and here we have negative charge. This point I call it A, this point I call it B. So this battery is a potential V, this capacitor is capacitance C1, this capacitor is a capacitor C2, and this capacitor has a capacitance C3. Now this point I call it C, this point I call it D. D, yes. Now how to find out that this combination of capacitor is a series combination? For that we again use a rule. Like if we move from A to B, we have only one path, and that path passes through all the capacitor. Like in series combination, we have three paths. If I move from A to B, I have different paths for the traveling from A to B, and each path passes through a single capacitor. Like this path goes through this one, this path goes through this one, this path goes through this one. But here we have only one path which is from A to B, and this path passes through all the capacitor. C1, like if I move from A to B, I have to move from A to C. This path passes through C1, then from C to D. This path passes through C2, then from D to B, this path passes through C3. So by this way we can identify that this combination is a series combination. So the first thing is about series combination is, if we want to move from A to B, if we want to move from A to B, then what will happen? We must pass through all the capacitor in succession. Like first we will move from C1, then C2, then C3, and finally we will reach to point B. So by this way we can identify that this combination is a series combination. Next, when a battery is connected across the combination, the potential difference V of the battery equals the sum of the potential difference across each capacitor. Like the potential difference across this capacitor is V1, the potential difference across this capacitor is V2, and the potential difference across this capacitor is V3. So the sum will give us the potential difference of the battery. And also the third thing is the charge Q delivered by the battery to each element of series combination has the same value. Like if Q charge is delivered by this battery, then that Q charge will appear through this capacitor, which also appear along this capacitor, which also appear this capacitor. So the potential difference of the battery is equal to the sum of the potential difference appear across the three capacitors. Let's say this is equation 1. We know that Q is equal to CV. From this I can calculate the value of V, which is Q over C. Then V1 will be equal to, because charge is same in all capacitors, so we have to use Q over capacitance is C1, and V2 is the potential difference across capacitor C2, which is equal to Q over C2, and V3 is the potential difference across capacitor C3, which is equal to Q over C3. Now using all these values, these three along with this in this equation 1, we get Q over C is equal to Q over C1 plus Q over C2 plus Q over C3. Now Q, they cancel with each other, so we have 1 over C is equal to 1 over C1 plus 1 over C2 plus 1 over C3. I can say that the equivalent capacitance 1 over C equivalent is equal to 1 over C1 plus 1 over C2 plus 1 over C3. Now this is the equivalence capacitance of three capacitors which are connected in series. If we have n capacitors which are connected in series, then the equivalence capacitance will be equal to 1 over C1 plus 1 over C2 plus up to 1 over Cn. So the equivalence capacitance will be equal to sum over I 1 over Ci, where I started from 1 up to n. Now this is the equivalence capacitance of n capacitors which are connected in series. Now in order to calculate the equivalence capacitance of capacitors connected in series, we take the reciprocal of each capacitor, or we take the reciprocal of the sum of reciprocal of the individual capacitance. Like first we have to calculate the reciprocal of individual capacitance, then we will add them, and after addition we will get the equivalence capacitance. Now one thing more, the equivalence capacitance of this series combination is always smaller than the capacitance of individual capacitor. I can say that equivalence capacitance is less than C1, equivalence capacitance is less than C2, and so on. So the equivalence capacitance of series combination is always less than the capacitance of individual capacitor. So this was all about capacitor in series. In the next video, or in this video, we will move towards what we call it, energy stored in electric field. Energy stored in an electric field. So here we have the new topic, which is energy stored in an electric field. So that I will do in the next video. Thank you.